Hello, this is Mr. Collier, and today we're looking at some exponential functions. So here's what an exponential function generally looks like. It consists of a number k that's not equal to 0 times a number a, which is a positive rational number. Okay, that means it's going to be positive, but it could be a fraction or a decimal. And we have c plus c, a constant as well. For the general function y equals a to the power of x, why can a not equal to 1? Well, if a is equal to 1, what happens is you get 1 to the power of x, and you'll always get y equals 1. So the graph of that would be just a horizontal line at y equals 1. So it wouldn't even be an exponential function anymore. It would just be a linear function, a horizontal line. So that's why a cannot be equal to 1. It has to be some other positive integer. Okay, let's look at a couple of real-life examples. This might be a bit hard to read here, but the number of water lilies in a pond doubles each week. In week 1 there were 4 lilies in a pond. Draw a table and write down the number of water lilies in the pond each week up to week 12. Plot the points from the table on a graph of the number of lilies against time. Draw a smooth curve through the points. So I'm going to do that with my graphing calculator. I want to go to Stat and Edit. Clear list 1 and 2. So I'm going to clear list, second function L1, comma, second function L2, and they are cleared. So I go back to stats now, and I have empty couple of lists. So what I'm going to do is here, I'm going to type in the week. So week 1, and we're going up to week 12, 2, 3, and so forth. Now in L1, or L2 rather, in the first week there was 4 lilies. And the information says here that the number of lilies doubles each week. So next week is going to be 8. Then it's going to be 16. Then it's going to be 32. Then it will be 64. Then it will be 128. So numbers are getting quite large. 256. 512, 1024, 2048, 4096, and for the last day it's going to be 8192. Okay, so that's the number of water lilies on day 12. Let's graph that. Actually, let's go to stat plot, and we're going to go put stat plot on. That will allow us to plot these points. So that's going to be on. We're going to plot a bunch of points from list 1 and 2. And then I go to zoom. I leave zoom 9. Okay, number 9 is zoom stat. So I'll click enter. And there are my points. So you can see that your points look like that. They increase very slowly at first, but then they increase a lot quicker. So if I were to draw a line through that, it would look something like this, or a curve through that. Actually, not really a line. Okay, and that's what this type of curve always looks like. It is going to be going up and up and up and quicker and quicker and quicker. So we call this type of curve, it's called increasing exponential here. It's also called exponential growth. Okay, so that's exponential growth. We're to do the same for the next one. Actually, let's go ahead and do that on the graphing calculator. I go to Stats and Clear List, L1, L2. Okay, then go to Stat, Edit, and I'll type in week 0. I'm going to go up to 10. Is this week 0? No, this is after 0 hours, 2 hours, and so forth. So 2 hours, 4, 6, 8, 10, and the amount of the radioactive substance is first 6,000, and then 3,000, and half of that is 1,500, and then it's going to be 750, and then half of that will be 375. And we have one more. Half of 375 is going to be 187.5. Alright, so I got my points in there. I can go to maybe zoom 9 right now. And here's what we have. Okay, so there's a graph. And this one's a bit different because it's very large at first, and then it's getting smaller and smaller and smaller and smaller. Okay, so it's getting smaller and smaller. So this one's called a decreasing exponential graph, or also called exponential decay. Alright, so now let's look at the general graph of the parent function. Alright, so this is y equals 2 to the power of x. That's the most basic we can get with an exponential function. We're going to complete the table and we're going to graph this on graph paper. So I like to start off with 0 because that one is usually the easiest one to calculate. So if we do 2 to the power of 0, we get 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. Now let's go back to this one. 2 to the power of negative 1, if you remember your exponents, that's the same as 1 over 2 to the power of 1, which equals half. Over here we have 2 to the power of negative 2, which is 1 over 2 squared, which is a quarter. So you can see the pattern here. We have a quarter. The next one's going to be 1/8. So you can see that 2 to the power of 3 gives you 8, 2 to the power of negative 3 gives you 1 over 8. These are just the reciprocals. Okay, on graph paper over the page, plot the points and draw an accurate curve of y equals 2 to the power of x. So we're going to do that on graph paper now. Notice there's no negative y values, so I don't need anything below the x-axis. So I'm going to make some axes here now. Oops, let me undo that. Alright. So here's my x and y axis. So 0, 1, 1, 2 are points that I have here. So 0, 1, I'll put that right there. 1, 2, so I'm going to call this 1 and 2 and 3 and so forth. 1, 2, 3. And we also have 2, 4, 3, 8. So 2, 4, 3, 8. So that's 5, 6, 7, 8. And we have negative 1, negative 2, negative 3. Those values are half, a quarter, and 1/8, so they get smaller and smaller there. And I'll draw a curve through this function as best I can. And over here what happens is it gets smaller and smaller and smaller. It never actually gets to 0. Never actually gets 0, approaches 0, so this is actually a horizontal asymptote here. Okay, so we do have a horizontal asymptote on all exponential functions. Alright, and asked what is the y-intercept? We can see that straight away from the table of values. When x is 0, y is 1. So the y-intercept is 1. Y-intercept is 1. Okay, we can see that on the graph as well. The y-intercept is 1. Number 4 here. What happens to the graph as x gets really big? Well, if you look at the graph, as x gets really, really big, then the y values get really, really big. Okay? So when the x gets really big, the y values get very large or really big. What happens to the graph as x gets really small? Well, as x gets really small, the y values get closer and closer to 0. Yeah, so the y values get closer and closer to 0. Alright, so let's try to fill in these blanks. This is called an increasing exponential function. For an increasing exponential function, the y values increase as the x values increase from left to right. The x-axis is called the horizontal asymptote. This means that it is a line that the curve approaches but never touches. The equation of the asymptote of y equals 2 to the power of x, so we just said it was the x-axis, so that is y equals 0.